Hello, in this video we're going to look at arithmetic series, and we're going to be solving some questions on arithmetic series, and I'll give you the formulas beforehand for you to be able to understand the questions better. So without further ado, let's go to what arithmetic series is. So arithmetic series is the sum of the first in terms of an arithmetic sequence. So you get arithmetic series when you add arithmetic sequence. So let's say, for example, you have 1. That's the simplest arithmetic sequence we can have. So if you add 1 plus 2 plus 3 plus 4, you get 10. So simply this is an arithmetic series. Yeah, so formulas you need to know for arithmetic series. There are actually two, but the end result for the two formulas is the same. What's different is what's given to you. So for the first formula, if you know the first term and the common difference, you can calculate for the arithmetic series. So Sn is equals to n over 2 times 2u1 plus n minus 1d. And in the second case, if you know the first and the last terms to be summed, you can easily use this formula. Yes, it's easier than if you know the first and the last term, you can use this formula. And you don't have to know this formula for if you're doing IBSL. This formula will be given to you in the data booklet. And another thing you should know is like that is crucial is S1 is equals to U1. The first term is the same as S1, and the second term is the same as S2 minus U1. So the general formula for this will be UN is equals to Sn minus Sn minus 1. So that's it basically. So let's go to the first example. So the first example, here we have an arithmetic sequence is given by this numbers. Find the sum of the first 15 terms. So we are looking for S15, and we know our U1 is 13, that's the first term, and the difference is minus 5 because it's reducing by 5 in each term. So using the first formula, because we only know the first term, so n over 2, remember the first formula, 2u1 plus n minus 1d. So this gives us 15 divided by 2 times the 13 is 26 plus 14d. Oh, the d, we know it's 5, so yes. So 15 divided by 2, 26, 14 times minus 5 is minus 70. So 15 divided by 2 times minus 44, that's 7.5 times minus 4.4. So this gives us minus 330. Let me know if this is what you got in the comment section. For the second example, we know the U1, the UN, minus 1 to 1 plus 80n, and we're supposed to find the sum of the first term. And in order to find this, you need to find U1 first. So to find U1, you just simply need to substitute 1 for n. So that gives you minus 103 as for U1. So to find S10, using the second formula, because you know U1, that's minus 103 plus the UN, which is this formula, you just need to add 10 inside it for us to be able to multiply. So S10 becomes 5 times minus 103 plus 59. When you solve this, you get 59 minus 220. And for the third example, an arithmetic sequence has the first term of 20 and the common difference of 13. So the first term is 13. The common difference, the first term is 20 rather. So it's 20 and the common difference, the d, is 13. So which term is equal to 228? So to first find the first equation, we need to use this formula, u1 plus n minus 1d. We know the un is 228. So, and the u1 is given to us as 20 plus, what we don't know is n, and that's what we're coming to find right now. D is 13 from here. So 228, 20 plus 13n minus 13, that is 7 plus 13, 228. So this becomes 221 is equals to 13. So n becomes 221 divided by 13. So that gives us 17. And we need to, this is just the beginning, we need to find the sum of this sequence. So using the is 17 becomes 17 divided by 2 plus the first term is 20. So we use the second formula for this because we know that the last term, that's 228. So this gives us, on your calculator, you should be doing it on your calculator, it gives us 2108. So for the fourth example, the arithmetic sum of the first n term is given by this. To find the first term and the common difference. So we know n is equals to n divided by 2, 5n minus 11. I told you already s1 is equals to u1. So u1 becomes 1 over 2 times 5 minus 11. If you put 1 in this value, so you get minus 3, because 5 minus 11, that's minus 6 times 1 over 2, that's minus 3. And u2 is the same as s2 minus u1. So first you need to find s2 first. So s2 is equals to 2 divided by 2. So 5 times 2 minus 11. So s2 becomes minus 1, because 5 times 2 is 10, 10 minus 11, that's minus 1. So after finding s2, u2 becomes easy, because u2 is the same as 1 minus 1 minus 3. So that becomes minus 1 plus 3, that's 2. So u2 becomes 2. But they wanted us to get the common difference. The common difference from the, if you haven't watched the first, the arithmetic sequence video, I'll link it to this video. So that becomes un minus 1. So 2 minus 3, that becomes 5. So the difference is 5 for this question. Yes. And the first term we have already found it, that's minus 3. Yeah. So for example 5, an arithmetic sequence has a third term. So u3 is equals to 11. And the sum of the first 10 terms is 10, is 160. So find the first term, the common difference, and the general term. So since u3 is 11, u3 is the same as u1 plus 2d. Using the un is equals to u1 plus n minus 1d formula, so that becomes 11 is equals to u1 plus 2d. And for s10, n over 2, that is 10 over 2, that's 5 times 2u1 plus n minus 1d, that's 9d, because n is 10, so 10 minus 1, that's 9d. So s10 is 160. So s10 is 160 here. So we use substitution method. u1 becomes 11 minus 2d. When you move 2d to the side, it becomes negative. So 160 is equals to 5 times 11 minus 2d plus 9d. So 160 is equals to 5 times 22 minus 4d plus 9d. So that becomes 160 is equals to 5 times 22 plus 5d. So you divide both sides by 5. You will get 32. So it's equals to 22 plus 5d. So 10 is equals to 5d. So d becomes equals to 2. And to find the first term, we simply put 10 here. We simply put the value of d in the u1 function. That's 11 minus 2 times 2. That's 11 minus 4. That's 7. So to find the general term, that is un is equals to u1 plus n minus 1 d. We know u1 is 7 plus n minus 1. D is 2. So 7 plus 2n minus 2. So that becomes 2n plus 5. That's the general term. Okay.
Moving on to our last example, we have considered the sequence Sn is equals to 2n squared minus 3,1. So Sn is equals to 2n squared minus 3,1 train, and find an expression for the general term and show that this is an arithmetic sequence. So the way we can do this is by using this formula, Sn minus 1. So un is equals to 2n squared minus 3n minus 2n minus 1 square minus 3n minus 1. So 2n squared minus 3n minus 2 times n squared minus 2n plus 1. That's the simplification for n minus 1. So then minus 3n plus 1. When you expand this, that's what you get. So 2n squared minus 3n minus 2n squared minus 4n plus 2 minus 3n plus 1. So 2n squared minus 3n minus 2n squared minus 7n plus 5 rather, because it's this 3 not 1. Yes, because minus 3 times minus 1, that's 3. So 2 plus 3, that's 5. So 2n squared minus 3n minus 2n squared plus 7n minus 5. So that is 2n squared counts as 2n squared, and minus 3n plus 7n, that's 4n plus 5. So we found for un is equals to 4n plus 5. And the way we're going to show that this is an arithmetic sequence is by using un minus 1. Just the difference. So un is equals to 4n plus 5 minus un minus 1 is 4 times n minus 1 plus 5. So 4n plus 5 minus 4n minus 4 plus 5. So 4n plus 5 minus 4n minus 1 plus 1 rather. So this becomes 4n plus 5 minus 4n plus 1. So minus 1. It should be minus 1, not plus 1. So it should be 4n cancels 4n. So 5 minus 1, that's 4. So our difference is 4. And this is clearly an arithmetic sequence because we have a constant term. So this sequence is increasing by 4 in each term. So this is this is an arithmetic sequence. So finally we have the conclusion. So for the conclusion part, what we have here is both formulas for the sum of the first n terms of an arithmetic sequences in our given IB formula booklet. This is the questions that I'm taking here are from Cogniti IB website. So it has to do it mainly has to do with IB. So you don't need to know the first two formulas, the SN formulas. Yes, and you also don't need to know the derivation of these equations. You just need to know them. You know how to use them. Yeah. Secondly, it's useful to remember that u1 is equals to s1. Yeah, this is very crucial when you're solving arithmetic series questions. And also u2 is the same as s2 minus u1. So for n greater than 1, the general term, the general formula for this right here is this one, the un is equals to sn minus. So thank you for watching my video. If you liked this video, please give it a like and subscribe. I'll be uploading more videos. Thank you.